Hello, I want to talk a little bit about function composition right here. First of all, let's start with the function. If you see that, that is f of x. It is function f. That is how it's said. It is not multiplication. It is not f times x. Not the case. It is notation, function notation. If you had this, that is not a -1 exponent, although that is what it looks like, so don't be trying to apply your properties of exponents right here. This is f inverse of x. F inverse of x. You could have something like this. That is f of g of x. F of g of x. And another way of denoting this, f of g of x. A lot of people say it looks like fog. That is a little tiny circle right there. It is not a multiplication, so don't get confused with that. Let's do a couple more right here. We could have, let's see, how about g of f of 3. That is g of f of 3. Not f of x, but f of 3, and it is g of f of 3. G of f of 3. You could have something like this. That would be g of all this stuff, so g of g inverse of x. Okay, so that is just a way to say a few of these. You're going to be getting some decent little practice with them and what they mean. It is really just a function inside of a function, and you could continue to do that for as long as you would like. So let's say we have a couple functions right here. How about a blue one? Let's go f of x equals 2x plus 3. And then let us have a very different color. How about red? You could have g of x equals 3x minus 2. Okay, those are our two functions right there. We're going to be doing some composition. We're going to be putting them together. We're going to be substituting some things together. We're going to be finding some inverse. Sounds like a lot of fun right here. So let us first start with, how about f of, I could put a 2 in there, you know, and that might actually be a really good idea. So f of 2. So what this means is I am inputting 2 where the x value is. So it would be f of 2 equals 2 times 2 plus 3. So f of 2 equals 4 plus 3, which is 7. Okay, you've been doing that for a long time. But something very similar to that, let's say I have f of, but instead of this time substituting in a value of 2, let us substitute in a different function. So how about this time I put in g of x. Check that out, okay? Instead of the 2 inputting the 2 where the x value is, you are now inputting a different function. You are going to be putting the entirety of g of x into f of x. So if I were to set this up, this would be equal to, well, f of 2 would be 2 times x plus 3. That is function f right there, 2x plus 3. Well, what goes inside of my blue function, f of x? We're substituting in g of x. So it would be 3x minus 2. G of x inside of f of x, and then you just do the cleaning up of it. Distribute. 6x minus 4 plus 3 equals 6x minus 1. That is f of g of x, the function inside the function. And we could do that from all sorts of directions. Let's flip-flop that for one moment. We will use our same two original functions, but this time, let's do, how about g of x, or g of 2, or g of 8? Or how about g of f of x? So now we are putting a function f, inside function g. Instead of substituting in a value of 2 or a value of 8 or whatever it may be, you are substituting in a different function. So we would get g of x, which is 3x minus 2. That is g of x, 3x minus 2. Well, what is inside of g of x? It's not a 2, it's not an 8, it is f of x. And f of x is 2x plus 3. You could now clean that up, distribute, and we would end up with 6x plus 9 minus 2 equals 6x plus 7. Therefore, g of f of x equals 6x plus 7. It is a function inside of a function. You can do crazy things. We can do kind of like, you know, if you've seen the movie Inception, a dream in a dream, we could do g of, well, what am I going to substitute into g of x? How about g of x? Awesome. That's pretty cool. G of x. All right. So I'm taking the function g of x, which is 3x minus 2. And what is getting substituted in there would be g of x, which is 3x minus 2. We clean that up, we get 9x minus 6 minus 2 equals 9x minus 8. G of x is 9x minus 8. Continuing on with this, let's do one more. How about we do f of, mystery time. What am I going to be putting into f of x here? How about g of, the mystery, it's not g of x. I can make this anything I want. How about g of 4? Well, this tells me to do g of 4. I can do g of 4. We did that. We did something very similar. We did f of 2. We could do that with the red. Whatever value we get for the red would then be substituted into f of x. So we could start this off kind of like a two-step process. First, I will do g of 4. So g of x is 3x minus 2, and I'm substituting in a value of 4. So it equals 12 minus 2 equals 10. Therefore, g of 4 equals 10. Well, think about that. Now this is kind of like a substitution. You've been dealing with substitutions all the time. Back to this original problem right here, f of g of 4. Well, what the heck is g of 4? You might tell me that it is 10 because we just found that out. So we could replace g of 4 with this value of 10. F of 10, can you do f of 10? Well, yeah, we did f of 2 right up here, so it is a very similar process. So f of 10 equals 2 times 10 plus 3 equals 20 plus 3 equals 23. Therefore, f of g of 4 equals 23. There you are. That is some nice function composition. We could do that with the inverse. We could put all these different things together. I do want to talk about one more little thing before I let you go. Let us say we had this. F of f inverse of x. Okay, thinking back to inverse and knowing that it is an undo function, you are understanding, hopefully, that, hey, I have the function, then I have the inverse, which undoes everything that is happening to the function. So my input values are known as my x. So if I have my function and my inverse, all the functions, all the operations on x will be undone with the inverse. So whenever you see the function composed with its inverse, you are always going to be left with your input right there, which would be x. If you had something like this, g inverse of g of x, hopefully you are recognizing that, look, I have g of x, I also have the inverse function of g of x. The function g of x and its inverse undo each other, and those would be canceled out. gone, and we would be left simply with my input here, which is x. And it works for values as well. I could come through, let's say I have p of p inverse of x, or excuse me, a value. So let's make that a value of, how about an 8 right there. So p of p inverse of 8. Well, the function p and its inverse have that nice characteristic of undoing each other. So all the functions on 8 will be undone, and you will be left simply with the value of 8. The function and its inverse undo each other. I'll be coming back in another video, and I will show you how to prove that two functions are inverse. Thank you.